In lesson 13, we're going to start talking about what it really means to be an inequality and maybe kind of what does it mean to be a solution to inequality. So let's jump in and look at our first exercise here. Tarek is trying to save $265.49 to buy a new tablet. Right now he has 40 and can save $38 a week. So every week he's saving $38. It says write and evaluate an expression to represent the amount of money he has saved after 2 weeks. Okay, so we know he has already saved the $40. Okay, in addition to that, so I'm going to put a plus sign, he can save $38 every week. So after 1 week, he saved $38, but this is 2 weeks, so he saved another $38. Right here, 3 weeks, $40. He saved the 38 from the first week, the 38 from the second week, and the 38 from the third week. I don't think we want to keep writing all those 38s down. So notice if we have repeated addition, that's multiplication. So I could say 40 plus 2 times 38. And if you grab a calculator, that's equal to $116. Okay, so he saved $116. Same thing here. But I could say that this is 40 plus 3 times 38. And if you type that into a calculator, it's $154. Okay, so I'm going to kind of use this new formula here. So 4 weeks, remember that 40 comes from his original amount. That's not being repeated each week. That's how he already saved. Plus 4 weeks of saving $38. Type that into a calculator, and that's $192. 5 weeks, the $40 plus 5 times $38. 5 weeks of $38 each, and that is $230. All right, scrolling down here, right? After 6 weeks, $40 plus 6 times that 38. 6 weeks, he saved $38, and that is $268. So after 7 weeks, right, we have $40 plus 7 times $38, which is $306. And last one we'll do today is 8 weeks. So 40 plus 8 times 38, which equals $344. Okay, so scroll up here a little bit. If you need to miss that, you can always pause it or go back. When will Tarek have enough money to buy the tablet? Oh yeah, he's saving money for something, right? So let's look. How much does he need? $265.49. So I look right here at week 6, and he has $268. That's enough money. Okay, so when will he have enough money? Well, week 6. But is that the only week he's going to have enough money? Like, does he have to buy it after week 6? Well, he has enough in week 7, doesn't he? And enough in week 8, and I'm guessing that'll be enough in week 9. So in this case, there's not really just one answer. It's not saying when is the very first week he can buy the tablet, just saying when is he going to have enough money? Well, it's going to be week 6 or after that. Anytime week 6 or after, he has enough money to buy his tablet. So if we want to write an inequality, those are inequality symbols that will generalize the problem. Well, notice what we did every single time, right? We had 40 plus, actually 40 plus, 40 plus, 40 plus, 40 plus. So I'm going to go 40 plus, and what did we add to it? Well, we did the number of weeks times 38, the number of weeks times 38, the number of weeks times 38. So we could do the number of weeks times 38. Now I'm going to be honest, we don't usually write multiplication like this. If you did, that would be okay. But I'm going to change this and say 40 plus 38W. Means the same thing, okay? But it's just on a little more technical way of writing it. And we wanted $265.49, okay? So can this be less than that? It has to be greater than that, right? Can it be equal to this? Sure, okay? It can be equal to it because remember, this is the amount he needed. Okay, he can have more than that, but he has to at least have that much. Okay, and so when we're writing inequalities, This is the type of thing we're going to be doing. It's not really much different than our equations we were writing, except we're using our inequality symbols now instead of an equal sign. All right, so let's look at one more example. 8 times an integer, that's the number 8, times means to multiply, an integer, I'll say x, minus 4 times the same integer, okay, x, is at least 36. All right, so we want to model this problem with inequality and determine which one of these works, 8, 9, or 10. Maybe they all do, maybe none of them do. So our inequality is basically what it tells us here. 8 times x. Now notice I don't write the times sign when I put these numbers together. If you did, that's fine, but you're going to get to a point where the less you write, the better it is. And then we're going to minus 4 times that number, and it's at least 36. Always pause here, at least 36. So if it's at least 36, can it be less than 36? No, it has to be greater than 36. Can it be equal to 36 if it's at least 36? Sure. All right, so it's greater than or equal to. All right, I'm going to leave it like this for now, but you absolutely could simplify this and do 8x minus 4x is greater than or equal to 36. I'm not, just kind of for getting us used to this, but you absolutely can. All right, we want to know if those numbers are solutions. Solutions, remember, make an equation or an inequality true. So if I said x was equal to 8, is 8, plug it in for x, times 8 minus 4 times 8, plugging in both these places, is that greater than or equal to 36? Now, I'm going to be honest, guys. I'm just going to type that into a calculator. And I'm going to say 8 times 8, which I know is 64, but 8 times 8 minus 4 times 8, and I get 32. So is 32 greater than or equal to 36? Nope. So 8, that's false. 8 is not a solution. Okay? So now let's do the same thing with x equals 9. And same thing, I'm going to plug that value in. I'm going to substitute the value in for those x's. And I'm going to go 8 times 9 minus 4 times 9. Is that greater than or equal to 36? 8 times 9 minus 4 times 9. Now, if you're like, well, Mrs. Messing, remember, that would just be 4 times x, and you're just going 4 times 9. That's the same thing. You're okay. You can do that. And what we get is 36. Is 36 greater than or equal to 36? Here's what people tell me. They'll give me the answer is it's equal to. This is not greater than or equal to. It's not a question. It's true if it makes either of those parts true. Is it greater than or is it equal to? Either one, solution. Okay. So now let's try x equals 10. Is 8 times 10 minus 4 times 10 greater than or equal to 36? Well, I haven't been doing it that way. I was going to say, well, 80 minus 40, well, that's basically what it works out to be, right? 80 minus 40, which is 40. Is 40 greater than or equal to 36? You don't say, well, it's greater than, but it's not equal to it. No. Either one makes it true. Is it greater than or equal to? Yes. Okay, so we say it's true. So notice the difference we're having now compared to when we were working on equations is now we're not just going to have one number equal, okay, one number being a solution. We are going to have a set of numbers, okay? So there's going to be more than one answer, and it's going to be really important that when we go to write that answer, we include our inequality symbol.